Hey everyone, so this is the second video about clustering, and we've seen clustering in the last chapter when it was about simple clustering where we just glue stuff together that is unbreakable before we looked at constraints. Now that we have a good idea about constraints, let's look at clustering in context of constraints. Because what clustering here means is also that we create, bunch of constraints actually that are connected in a different with a different strength than the rest. And this then creates like groups of pieces that are glued together differently than the rest, which also gives us a more natural breakup. But the difference to the clusters before is that they are still breakable in themselves. Now, before we look at the clustering, one small thing, there is something similar already built in, and that is in the RBD material fracture. We know that the constraints come out directly of the node. And here's something interesting, the level multiplier, which means with every level here in the primary fracturing, the constraints go stronger. This does a little bit of what we're trying to do so that pieces stay together. But simply in practice, when you do this, and let me actually adjust the numbers to something that works, the result is not what we want, because sure, we keep pieces together, but you never really feel like, there's certain groups of pieces that stay together. That's the big problem about this approach. And while it's a good idea, in practice, it's not giving you the same results as the clustering that we will look at. So you can sure combine it with a level multiplier, but what we want to do is a different technique. So let's have a look. So first of all, I have used an RBD material fracture here because it's quicker. And then I'd still use the RBD constraint properties to override my constraints to glue. And the reason for that is, of course, in the RBD material fracture, there are already constraints built in set to glue. But the problem here is that you can't find the propagation iterations. For some reason, you can't change them here. Sure, of course, what you could have always done is you create a primitive wrangle and then just override them directly and then maybe set it to 10 or something. This would have been completely possible. As you can see, this works, but the RBD constraint properties makes it a bit easier because it's already built in here. And I think that's, here it is. This is easier to understand, but it's in the end the exact same thing. Now, why did I set the propagation iterations to 100? Because I want I make it easier for our pieces to break. So when my box here falls down, I actually want it to break a lot, so to say. And you can see here what problem we currently have. The glue strength is too weak so that everything breaks instantly. And because of the very high propagation iterations, but kind of the impact will rattle or will move through our whole object. Makes it easier to see what the clustering actually does. In this case, our glue strength is too weak and basically every connection will break at some point. Now let's change this from currently 100 to maybe 10,000, which is funnily enough the default. And when we run this, it's now so strong that nothing breaks. Cool, okay, let's find something in between, maybe 1,000. And what happens? It's still too strong. All right, let's try 300. Yeah, and here you can see what happens. Wherever there is an impact, it breaks now. Okay, but that doesn't feel very natural because now, okay, there's more dynamic because I have at least one piece in the middle that stays intact. It still feels weirdly odd that, it either breaks it completely or not at all. Where is, a variation? So we can now play around, maybe try to find a better strength number so that it feels more natural. But as you can see, it's actually not as easy. It always kind of either stays together or breaks completely. And the reason for that is that the strength is set the same for everything. Because when we look here at the strength, they all have 400. Okay, let me show you the alternative to this. We have two options for this. First, we can use the glue cluster, which is a node explicitly for the constraints. And then there is the RBD cluster that we've already seen. And by default, this is set to combine pieces as we've seen in clustering 1. But you can also change this to group constraints, which then only is used for constraints. Let's start with a glue cluster because it's easier to understand. And when you look through it, you can actually see again the clusters. So let's increase or decrease the size so that we get more clusters, maybe something like that. And you can control again the random detach. We turn this off for now for understanding this. And then there are basically two different settings. The internal strength, which is between the pieces, which is set to -1, which means it's infinitely high, and the cluster to cluster strength, which is the connection between them. Let's see what this does for now. And it already gives us a much more interesting result because now bigger pieces stay together. But in the end, what we have now is the same as clustering 1. Why? Because the cluster strength between the clusters, which you can see here actually, and when we look here, it's either 1 or -1, which means infinitely high. Then there's no way to break them up. So what we can do instead is we could say the internal strength should be 100 and the strength between the clusters should be 1, so weak. And then we get 2 breaks basically. An easy break between the clusters, but the clusters themselves can still break. And I think, yeah, this is already a pretty good example of this, and explains why this is such a good idea. You still feel there are big pieces, but those big pieces can still break. For example, if now there would be a train or something running into this, those pieces would be able to break again. And this makes it pretty natural. So let's move on and let's have a look at the RBD cluster. It works the same way, it just needs a bit more work because all the RBD cluster set to group constraint does, it doesn't actually change the strength, it only creates a couple of groups. Why? Well, so that we can change them ourselves. Because when you look at what is created here, when we look at the primitive constraint strength, this hasn't changed. 380 was what we have set before in the RBD constraint properties. The only thing that came on top of this are those groups. And that is cluster to cluster, cluster to piece, intra-cluster, and piece to piece. Now, cluster to piece means between the cluster and the detached. So let's quickly look at those groups by just blasting them out. So we could look at our constraints and only show the, let's say, cluster to piece and delete everything else. And those are the connections basically between the big ones and those random detached ones, which are still visible when you look at this, you can see it. Those, colorful ones that, are random. And if I dial this down to 0, you will see there is no connection left. So this is what the cluster to piece is about. This is a topic by itself. You can play around with this, but the more important ones are cluster to cluster between the big pieces and inside of the cluster, the intra-cluster ones, those ones. So what we want to do is basically control them separately. So we need a primitive wrangle again, because again, those constraints are primitives and we change the strength as a primitive attribute. And let's change the strength of the inner connections again to 100 because that worked well. And only do this for the connections between the clusters, so cluster to cluster. And before we move on, this is cluster to cluster. Let's also lower the, no, sorry, I actually did it wrong. It's not, this is not cluster. I didn't want them to be cluster to cluster, but I'm talking about the inner ones. They should be strong. So the intra-cluster ones, sorry. So those are the intra-cluster, so the inside of one cluster. And then this is the cluster to cluster, exactly. And those should be weaker, so maybe 0.1, so that they break easily. And this just allows us to have a bit more control because we now have our own groups and can do whatever we want with them. And let's see how this behaves now. And yeah, okay, everything is too weak. So let's play around with this. And let's say the cluster to cluster should be weak, that's fine, but the intra-cluster should be stronger, maybe 10,000. And yes, and this is exactly what's happening now. The pieces break only on the edges between the cluster, because we set the cluster to 0, 1, and the intra-cluster to 10,000. Let's lower this, of course, so that we get a nice mix that we're actually after. Yeah, that's still too strong. Okay, let's not waste too much time because it's all about the concept, but I think you understand it. It's about being able to differentiate between the different connections and then being able to control them separately. And the glue cluster has all of this kind of built in, which can be an advantage if this is all you want to have. but the RBD cluster simply, when you set it to group constraints, creates groups, and then you can yourself control what you want to do with those groups, and can add more complex rules, maybe based on another noise or something like that. I don't know, but you get the idea. So when we put them side by side, this is how the RBD cluster approach looks like roughly with the group constraints, and here the pure glue cluster, which is the simpler version but the same logic, looks like this. And I think this is the one I like the most. I would have to check why this looks better. If we build this ourselves with the RBD cluster with the groups, then let's see how this looks like, and let's try to make them look similar. And the difference here is that the size here is different of the constraints. So let's adjust this so that our RBD cluster has the same size of clusters. So something like this. Let's quickly have a look at the strength. Okay, I still see a lot of 380s, and the 380s are in the group cluster to piece. Okay, so let's maybe weaken them as well. So let's not set the strength only to cluster, but also cluster to piece. It seems to change the behavior quite a lot. Yes, and this is pretty similar to the version with the cluster piece. So, okay, as you can see, the results can be very similar. This one is a bit simpler, and I think, prefer that. But the RBD cluster allows you to, much more in detail control how the settings are for each group. But either way, in both cases, the idea is that you have even more control how your stuff breaks up. So still having big pieces that feel natural, but those pieces then are still breakable afterwards. And that's the main difference to the first cluster video we saw. So either way, I hope this is helpful. Thanks very much and see you later. Cheers.